All right, I'm going to take you through the steps on how to calculate the size that a footing needs to be and able to support a calculated load. And so our case, we have a column right here. And so this is our column, so I'll go ahead and label it. It's our column. We have two girders that are hooked to the column. So we have a girder here. We have another girder over here. So go ahead and label those. We have two beams that are hooked to our column, here and here. Beam one. Here's our other beam. And so what we're going to be doing is calculating how big does this footing have to be down here to support all the weight that each of these girders, beams, and the column are supporting. And so right here is our footing. So again, what we're doing is figuring out how big does that footing need to be. In our example here, we're going to have two floors. So we'll have this column is supporting both the roof and the second floor. And so the first thing that we'll do is we'll go ahead and we'll figure out the total column load, or how much load is being applied to that column. And so for the sake of this example, we're going to pretend that an engineer has already done the calculations for the live loads and dead loads and figured out the loads on each of those beams and girders. And so for our roof beam reaction, we have 5,000 pounds. And so what we're saying is at this end of the beam, there's going to be a 5,000 pound reaction force on going into that column from this point on the beam. All right, and so we have two beams, and so we need to multiply that number by 2, which gives the roof beam reaction of 10,000 pounds. We also have the roof girder reaction. So here's our girder, here's our other girder. We have two of them. So for the roof, we have 20,000 pounds. Now remember that in this example, we're going to support the roof with this column, but we're also going to support the second floor. And so our second floor beam reaction, right here and here, has 13,500 pounds. So we have to multiply that by 2, and we get a total of 27,000 pounds. Our second floor girder has a reaction of 27,000 pounds. So we have to multiply that number by 2, one for each side, and we will get 54,000 pounds. Okay. The last thing we need to know is how much does the actual column weigh itself. So our column weighs 1,500 pounds. We do not need to multiply that column by 2 because there's only one column supporting all that. So it's just equal to 1,500 pounds. So you add all those numbers up and you get a total column load equal to 112,500 pounds. So that's the number we'll use in our calculation when we're trying to figure out how big do we need to make that footing. We're going to have another given in our problem, and so that's going to be the actual thickness of this footing. And so for this standard project, we're going to say our footing thickness is going to be equal to 1 foot 9 inches. And so if we convert that number to feet so we can use it, it would be 1.75 feet. And so that is our footing thickness that we'll use. All right, now we'll look at our formula sheet, and we're going to figure out the soil-bearing pressure due to the footing. And so if we look at our spread footing design formula, we can see that the soil-bearing pressure of the footing is equal to the thickness of the footing times 150 pounds per cubic foot. All right? And so we'll go ahead and run through that calculation. So I'm going to write soil bearing pressure we're going to be calculating. And so the soil bearing pressure of the footing is equal to the thickness of the footing times 150 pounds per cubic foot. Let me zoom out so you can see that. There it is right there. So we have the soil bearing pressure of the footing is equal to the thickness of the footing times 150 pounds per square foot. And so we'll go ahead and put our equal sign. We know the thickness of our footing from our calculation down here is 1.75 feet. Times 150 pounds per cubic foot. We get an answer of 262.5 pounds per square foot. All right, the next given that we're going to have is based on the type of soil in your construction area where you're building the construction. We'll have different soil bearing pressures. And so for our case, we're going to say that our soil bearing pressure is going to be equal to 3,000 pounds per square foot. And that is based on a silty or a gravel type soil. And this number is just from a table. And so there's soil bearing pressure tables, and there's maps that tell you what type of soil is in the area that you're building. So people have already figured all of that stuff out. So the next thing we are going to do is, if we look at our formula sheet again, we're going to calculate the allowable soil bearing pressure, or the net allowable soil bearing pressure, which is equal to the total allowable soil bearing pressure minus the soil bearing pressure due to the weight of the footing. All right. And so if we go ahead and write out our what we're doing here, if we calculate the net allowable soil bearing pressure, that is equal to the calculated, or the total allowable soil bearing pressure and again this is on your formula sheet, minus the soil bearing pressure due to the footing weight, which is what we calculated in the step before. So we'll put in our information. The allowable, based on our soil bearing pressure that we got off the table, our soil type at our construction site, is 3,000 pounds per square foot. We're going to subtract that from our soil bearing pressure due to the footing weight, which was 262.5 pounds per square foot, and we get a answer of 2,737.5 pounds per square foot. All right, the next thing we're going to need to calculate is the area of the footing. And so if we look at our formula sheet, we have a formula here that the soil bearing pressure is equal to the column load applied divided by the area of the footing. And so if we go ahead and do a manipulate that formula, here we could say that the area of the footing, by multiplying A by both sides and then dividing Q by both sides, we could say the area of the footing is equal to the pressure of the column divided by the soil bearing pressure. All right, and so that's going to be our formula that we'll use. So we'll say that the area of the footing needs to be equal to, really it needs to be greater than or equal to, so let's go ahead and put that. It needs to be greater than or equal to the column load applied divided by the soil bearing pressure. Okay, and so our column load applied, if we go back over here, we can see that their total column load was 12,500 pounds. We divide that by our soil bearing pressure. So we just calculated that, 2,737.5 pounds per square foot. Divide those numbers. This number should be 112,000. Sorry, forgot that first number. We divide those two. So get on my calculator. 112,500 divided by 2,737.5, and I get about 41. The area has to be greater than or equal to 41.1 square feet. Okay, and so the next thing to do would figure out the shape. Most footing shapes are square, and so the area of the square is just equal to the side length times 2. So if we take our number here, 41.1 feet squared is equal to the side length, or in our case, the area of that column, x squared. We square root each side, and we get that our column should be, or excuse me, our footing should take the square root of 41.1.